The James Webb Telescope has now produced another image that indicates that something is seriously wrong with our universe. Either our space is going crazy, which would indicate that it has some sort of intelligence, or our scientists simply got it wrong. The fact is that since the launch of the new telescope, we have never experienced a crisis of this kind in world science. It seems as though the new findings are trying to tell us something urgent, but so far, scientists are arguing more than they can present us with real, new facts and truths. Does this mean the end of everything? Since the JWST showed us images of galaxies that are so old and perfect that they shouldn't even exist, this was the start of a drama in modern science that continues to this day, with more and more images revealing even more bizarre phenomena and impossibilities. The idea of a homogeneous universe dates back to the early 20th century, when Albert Einstein introduced the cosmological constant in his general theory of relativity, which described a static universe that neither expands nor contracts slightly. However, there are now dozens of indications that the universe is actually homogeneous, challenging some of the fundamental assumptions about the nature of the cosmos. Nothing in the young universe is the way scientists thought it would be, and it is also evident that the entire universe is not the way our scientists thought it would be. Later, it became evident that the universe is extremely dynamic and that nothing in it is static. Nevertheless, physicist Alexander Friedmann concluded that Einstein's field equations also applied to an expanding or contracting universe. Following George L.T.'s proposal of the Big Bang theory, which postulates that the universe expanded from a single point, the concept of a homogeneous and isotropic universe emerged. This theory is based on the so-called cosmological principle, which holds that the universe is homogeneous and isotropic on large scales, meaning that it appears the same everywhere no matter where you look. Let's contrast this with an isotropic, uniform landscape. The terrain would resemble a huge, unending desert with uniformly scattered sand and no hills, valleys, or other geographical features. The scenery appears the same everywhere, regardless of direction or location, and there are no unique or preferred locations in the universe, which would imply that stars and galaxies. It may seem odd to think of the entire universe as a landscape, but upon closer examination, this idea is not so far-fetched. We have galaxies with millions or billions of stars that travel around the universe along filaments and come together in groups. We also know of giant empty spaces, voids, black holes, and other phenomena. Cosmic nebulae and other phenomena are roughly evenly distributed in space, but recent discoveries by the James Webb Space Telescope and other astronomical observations have shown that the universe may not be as homogeneous and isotropic as previously believed. Each of these items participates in the cosmic show. Researchers have recently found that there are roughly 0.5% more quasars on one side of the sky than the other. Quasars are incredibly luminous galactic nuclei driven by super-large black holes. The second discovery that contradicts the theory of a homogeneous and isotropic universe is the existence of two enormous cosmic structures, the giant arc and the big ring, that are phenomena formed by galaxies and galaxy clusters. These structures are so large that they surpass the scale on which the universe is supposed to be homogeneous and isotropic. In other words, they are so large that our measurement techniques fail here. Before these recent exciting discoveries, there were already indications from the different expansion rates of the universe. Here, different methods of measuring the expansion rate of the universe gave different results. This difference is known as the Hubble tension. Megastructures like these indicate that there are the equivalent of high mountains within the universe's landscape, and no one currently knows how they emerged from or fit into the overall structure. There could be a previously unidentified layer of the universe or a force that is responsible for the measurement differences, or the universe is not expanding uniformly because of a cosmic mountain somewhere in the way of the new telescope. If the universe is not the same everywhere, this would explain why it is not expanding uniformly. In the meantime, scientists have used the James Webb Space Telescope to confirm the Hubble tension. Now, let's take another look at the cosmic background. Radiation, or CMB for short, which is thought to be the afterglow of the Big Bang and is essentially uniform microwave radiation. Why does it show an even distribution of matter? Do you want to know a really interesting fact and an amazing theory? Around 380,000 years after the Big Bang, when the cosmos had sufficiently cooled for protons and electrons to interact to form neutral hydrogen atoms, the radiation first appeared. The universe was a hot, dense plasma of ions and electrons prior to recombination. These collisions ensured that the matter and radiation in the universe were tightly coupled and in thermodynamic equilibrium during this time. The dense matter strongly scattered the radiation, preventing it from traveling long distances without encountering particles. As the universe continued to expand and cool, temperatures eventually dropped below roughly 3,000 Kelvin. Electrons were able to combine with protons to form neutral hydrogen. The uniform distribution of CMB radiation led scientists to believe that the universe was almost homogeneous and isotropic, which may have been the case more than 13 billion years ago when it was smaller. However, what if the universe is not expanding in an empty space, but rather in a space where something already exists? The distribution of matter shortly after the Big Bang may have been homogeneous, but the expanding universe encountered obstacles that disrupted the homogeneity. These obstacles can be anything, but they all lead to fantastic theories that excite space fans but give scientists headaches. There is nothing outside of this space, according to old theories, and quantum physics has already demonstrated that nothing cannot exist. However, what if our universe expands into a space where other universes or dimensions and previously unknown structures exist? This would obviously mean that it encounters obstacles that send other universes or dimensions away during its expansion, or that they exert resistance on our universe, making the initially homogeneous Big Bang become inhomogeneous as a result of these encounters. You won't believe it, but some brave researchers who back theories like the multiverse have made an intriguing analogy. Such considerations are fascinating, but despite the numerous contradictions in astrophysics, they currently receive very little official attention. The Earth was a glowing hot ball with evenly distributed matter at first, but later a heterogeneous structure developed. At least on the surface, we have large oceans and land masses that are not necessarily evenly distributed across the globe, but rather more randomly. The Pacific is huge, just as the Eurasian continent is very large, and Africa is almost directly adjacent. On the other hand, the American continents are elongated and slender, and we also have more heterogeneous structures. Within the oceans and on the continents, deep-sea crevices and trenches shallow sections. What can we learn about the universe from this inhomogeneity? Well, our Earth clearly demonstrates that the planet has changed over millions of years from a homogeneous world into a heterogeneous world, at least in part. The rocky planets, all, exhibit signs of such changes. Lagoon seas, deserts, high mountains, and sparsely populated regions have formed on the land masses. Mars. If we look at the rest of the solar system, the gas giants are homogeneous planets that have likely barely changed in appearance over millions of years. But the diversity of our planets alone again demonstrates the uneven distribution of matter and gas within a solar system. If we return to the landscape of our universe, it is therefore quite conceivable that a cosmos takes on heterogeneous features during its evolution. The latest discoveries of the James Webb Space Telescope have shown that our science has been wrong in many ways. The old cosmology is collapsing, and we may now have to acknowledge that even physical forces undergo evolution and change over time. Subscribe now and look forward to many more exciting videos.